Hey, welcome to another video. Thank you so much for watching this one. And thank you if you did watch the last one, which was configuring and verifying the IP version 4 and version 6 access list for traffic filtering. But on this video, we're going to be doing some analyzing network traffic with Wireshark. So just going to do a few things. I'm going to, of course, download Wireshark and capture some packets. And I'm actually going to do some packet analysis a few times as well, verifying the output logs that we do with the that we get from the analysis, and also do some packet jumping. Let's go ahead and get started. All right, so I have Wireshark finally downloaded. So now we're just going to do some packet capturing. All right, so just bear with me a second. There it is. All right, let's look at promiscuous. Yeah, there. Perfect. So let's hit start. Just capturing a few things. So it's just showing the interface here with the Ethernet card assigned. All right, so I'm just going to leave it running for a few minutes to collect some information that's flowing across the network devices. Right. All right, so I just rebooted the server 801 just so I can observe some packet capturing as it boots. And we'll see actually in the protocol here, we'll see some ARP data as well as TCP traffic. I'm just scrolled up here. But we want to look for definitely the ARP request when it starts usually. But just to bear in mind the IP for this address, we'll have to look for it here. Let's see. So it can actually stop. I've had it running for a little while. All right, so now we're going to do some packet analysis now that we've captured some data here. So there's a lot of information, as we can see, generated throughout the networks, and Wireshark usually does an excellent job of organizing it. However, there's still a fair amount of information to go over initially, right? So as far as analyzing the captured information, I'm just going to explore the details, right, of traffic flows and how to understand them using the main interface. So I'm also going to list them according to different tabs and then move it into basic filtering techniques. Let's see. So let's look at a few display options, right? So we got the packet number here, right? And we have the time, the source, which is the source IP address, the destination IP address, the protocol, of course, the length of the packet, and any extra information, right? Let's first take a look at the protocol here. Actually, let's see. I like it in alphabetical order. All right, so I just need to find the results. Okay, here it is. All right, so looking at the results of the ARP sessions, right? So from this method, usually all the communicating devices that are calling out to check each other's IP addresses, we see that all the addresses listed for all switched on devices, which are connected to the same Ethernet adapter. We can see calls for 0.4, 0.1. Those are pretty much it. Looks like 0.250, right? And what it does is it's asking for information about who has these particular IPs or which is the server, right? We also see the devices establishing their addresses, right? So for instance, the 0.4, which is the Win10 server, confirms this address location. That is, let's see here, 5569, right? All right, so let's scroll a little down here. This is when it reboot here. All right, so usually what happened when I rebooted 801, so usually the frame can be sometimes seen as making a gratuitous request via a broadcast, effectively setting a source and destination address information against his IP. Let's see. Actually, you know what? Let's see here. There it is. All right. All right, perfect. Now, if another machine did own, let's say 0.5, right? Um, then it would, at least 801 would detect a duplicate IP address and then prompt us to change the configuration. But what Wireshark does is decodes the OUI, and then we can expand the MAC fields to usually decode the multicast broadcast bit and the locally administered bit, right? So now we're going to explore the capture a little bit further. So let's see. Let's actually go back to the purple, or maybe some other colors here as far as different indicators, right? So normally, let's actually take a look here. Light blue usually normally means UDP traffic, right? Dark blue can mean DNS traffic. Green looks like we don't really have any here, at least I don't see any so far. Usually has TCP traffic, and then black, unfortunately, if you see that the TCP packet maybe may have some problems. So let's actually take a look at a particular protocol. CDNS. All right, so I see queries going out to our domain, and then another query is being made for updates. Looks like here. Okay. All right, so let's actually clear this out. Then let's take a look at the TCP here. All right, so we can view plenty of TCP traffic from all the devices that are at least using that protocol. There's a lot of information that's flowing, which can be overwhelming to inspect, right? Let's actually take a look at some hypertext transfer protocol as well. A lot of green here. There's the green. All right, so now we can actually, now that we see the HTTP traffic, let's investigate any IP devices that may have been like well-known, may have been using that well-known port and looking at internet traffic coming and leaving the devices. So I'm actually going to just click on any of these here. All right, and then let's follow the TCP stream. Okay. All right, so now we see the output, right? Actually hit close here. Look for it another way. All right, so let's see. All right, perfect. So it's just displaying the filtering for an IP, and we can view all the traffic that's pretty much flowed from DC01 since the recording began. All right, and we can also take a look at the number to see in the order the results to order the results as they were captured, pretty much. All right, so we also know that Wireshark, the information can be a bit vast and confusing sometimes to view in any normal environment. And while scrolling through like this, like mountains of data, pretty much, it's easy to miss any key pieces of information. So reporting tools in different formats of viewing data visually and through table formats are useful in order to understand the environment fully, right? So we're actually going to do some further analysis of our packets that we have. So we're going to take a look at displaying some capture information. So we're going to take a look at different methods of output to view the data in like a more appealing and rewarding format. So we're just going to view the key more rapidly, and we can discern if a more detailed investigation is required. Right, so let's take a look at statistics and resolved addresses here. All right, so typically hosts that have their addresses resolved from an IP to their names will be listed in the initial section. We can clearly identify 801 and DC01 from this list, so that information can be confirmed in the topology. I'm just gonna hit OK here. All right, so let's take a look at here. So it just looking like it's just showing us all the details in terms of packet types and how much information flowed in each protocol type. Like for example, right, if we were interested in HTTP packets only, right? Here, let's see if we have I'll just use TCP, right? Then we can apply the filter and then hit select it, right? Then it would show us in the background here, as you just saw, at least for a split second, look like it changed. And we can actually see it here that it's been filtered, all right? Let me close this out. So we're back on the main screen, and we can see TCP being applied as a filter, which then informs Wireshark to display those packets in the capture window here, right? All right, so now we can actually discover any devices to communicating directly. So let's actually clear this filter again. And let's take a look at statistics. And let's take a look at some conversations. All right, so let's take a look at the TCP tab. Make sure that's clicked. Right, so it's important to understand that even though a device is not being directly used by a person, it's always having a conversation on the network or trying to communicate out unless very specifically programmed not to. So we're going to take a look at some graphical information regarding this capture. So let's actually take a look at the, actually go back here again. Let's go to the graph here. All right, so this image just shows all the packets as a line graph and the TCP errors as a bar graph seen in the same diagram, but I'm actually going to take these out. So we can just look at all packets, right?